if g of x equals the quantity x plus 2 squared for x's that are greater than or equal to negative 2, then what is the inverse of it? Well, first of all, some of you get confused by this. This allows us to put boundaries on this function so that when we would graph both the original function and we graph the inverse, we know that they would reflect across this line. So we're putting some limitations on how much of this graph we see. That's basically what this is doing. Now, how do we decide upon this number? This is just extra information. How do we decide upon this number? Think of this inside and go, what number would I need to place in here to get an answer of 0? And the answer is negative 2. That's how we come up with that. Give me 1 second here. So the next thing is to find this inverse. I'm going to first start by switching the x and y. So it was g of x. Remember, I'm going to put it first as a y, and then I'm going to switch the x and y. So when some students go, what do I do with this? Okay, when you're finding the inverse, remember g of x really becomes a y. And this has nothing to do right now with the inverse in terms of actually doing the operations to compute the inverse. So I make the g of x a y, I switch the x and y, I take the square root of both sides, I take the square root of both sides. Remember, I have a plus or minus here. So plus or minus the square root of x equals y plus 2. The last step will be to move that 2 over to the other side. So I have y equals the square root of x. And now when the 2 comes over, it's subtracted. Now notice the 2 is not inside. And I do have a plus or minus here. So one time I'm going to put a plus. The other time I'm going to put a minus. Now I'm going to go into, so here are my two options, and I need to decide which option really is it. So I'm going to put it, so I'm going to go into Desmos right now, and in Desmos, I'm going to type in that first equation. So instead of g of x, I'm just going to put y equals x plus 2 quantity squared. Now, remember there was a restriction. If I come back here, here was the restriction. It said only graph this function where x's are greater than or equal to negative 2. How do we put that into Desmos? Well, you're going to use those curly Q type parentheses. And we simply type in what we see. X is greater than or equal to negative 2. So it's graph the function, and it's only limited at this portion. Remember, if things are going to be inverses of one another, they need to directly reflect across the line y equals x. That's one of the ways. So I have two options right now. I'm going to plug this in and see if it's a direct reflection from what I already have, and if it's not, then I'm going to switch it to a positive. So my next one will be y equals negative square root of x. Notice that I need to use the arrow to go behind the square root, subtract 2. Now when I look here, I can see that, well, if I took this and I reflected across the line y equals x, I wouldn't get this, right? So I'm going to come back here. I know that this option is not the case. I'm going to go on to the next one. So all I have to do is turn the negative into a positive. Turn the negative into a positive, and I go, oh yeah, that works. Remember, if somebody asked you to prove this, which is not the case, we could do things like, okay, 4, 0, so domain, it has a point of 4, range has a point of 0. If I flip them, I should be able to get 0, 4, and you can see that I do, okay? So how do I directly write this in? If this happens to be a problem that you had to plug in, you do have to make sure to write it in the correct inverse notation, and that means that you have to be able to show that this is an inverse by putting that little negative 1 with the g of x. So this is the correct answer. I want the square root of x, subtract 2. So this particular question on your test, this is the district benchmark test. I don't have access to edit any part of this. And so that's why I have these little asterisks here. It's because the question directly says, you have been asked to find the inverse of a specific function, and what would be the first step? Well, we know the first step, after we assume that this is a y, would be to switch the x and y. But whoever created this test made a mistake. Obviously, they're going to have to switch it before next semester starts, but they haven't made the corrections yet. And so for that reason, I put a little dot, dot, dot. I'm unable to edit this benchmark exam's direction should have said, after switching the x and y, what would be your next step? So if I switch the x and y, this is what I have. This is what I have, okay? So this is what I have. Now, what would be the next step here? The next step would be to start by getting rid of this number, so I'd add 5 to the other side. So adding 5 to both sides. So we go plus 5, and then that would be my first step. Again, when I just look at this, the first step really would have been, it should have said, after you switch the x and y, what do you do? But they forgot to put that. So I do want you to keep that in mind. When I provide you the link to the test today, I will make a little asterisk note and say, assume for this particular problem that they should have said, you've already switched the x and y, now what is your next step? So we have two functions, h of x and k of x, and we are told they are inverses of one another. If they are drawn on the same graph, then which of the following would be true about these? So let's go over what we know. When we look on a graph, before we even read this, we know when we look on a graph, there's two things that can be true by just visually looking. One is they reflect across the line x equals y, and two, the domain of one becomes the range of the other, and the range of one becomes the domain of the other. So let's just glance through these. By reflecting the coordinates grid over the line x equals y, we know that one function will land on the other. That means if we fold along this line, they would lie on top of each other, they would be equal. Correct answer is. This is kind of tricky how it's worded, but it goes back to what I just said in the last problem, that the domain of the original function becomes the range of the inverse, and the range of the original becomes the domain of the inverse. So we have two functions, and we're told they're inverses of each other, c and d. And we're told that for this particular function, remember, this always represents the x value, this always represents the output, the y. Input x, output y. So we're told we'll call this the original function. We're told that we have an ordered pair, 5, negative 11. Now, how did I know its order is 5, then negative 11? Again, because right behind the variable represents the input, in this case the x, and the output is always last. So this happens to be for the original, and we're asked, well, what would be, if they're inverses of one another, then what could we say about the inverse of c of x? Okay, remember, we just flipped these. So then for d, the inverse of c, d, negative 11 would be the input, and 5 would be the output because the domains and range just flip. So if I have negative 11 here, the output would be 5. Next question goes back to what I talked about in number 1. It's saying that we need to sometimes create restrictions like we did here. If I go back to this graph, well, we created a restriction, so we didn't see enough. I just take this away. Look real quick. If I take this away, and you look at the graph, you'd say, well, if I reflected this entire parabola across the line y equals x, I wouldn't get just what's in green. And for that reason, we have to create this restriction. By creating that restriction, then I can reflect the red across the blue line, and I get exactly the green line. Now, how do I know to make this exact restriction? If I come back here, remember, we look at the inside and we go, what would make this equal to 0? So what can I input in for x, and this portion becomes 0? It would be negative 2. It would be negative 2. Okay, so let's come down here and look at problem number 5. Which of the following domains represents where the function is invertible? And that means, what would I need to do here? What would I need to do here? Okay, so the same concept. I have this, right? And I need to know what number goes here. So you ask yourself, what can I plug in for x? What can I plug in for x that makes this quantity equal to 0? And the answer is 1, because 1 subtract 1 is 0. X has to be greater than or equal to 1. Correct answer is B. What is the domain and range of the inverse of this? So first I need to find the inverse. So remember, to find the inverse, first g of x really means a y. And to compute the inverse, I'm going to switch the x and y. And the only reason, you've heard me say this a lot of times, the only reason we use the log is to solve for a variable that's in the exponent position. So I need to get rid of the 2. So log base 2 on the left, log base 2 on the right. And then I bring down everything that was there. Now, why do we do that? So on the right-hand side, these don't just disappear. They turn into a 1. And 1 times y is 1y. Now, this is the inverse. This is the inverse of this. Okay, so we want to know, what is the domain and range? Well, there's a couple ways we could have done this, by the way. One way is I could have just graphed this function and figured out what is the domain and what is the range. I could have just graphed this function and figured out what is the domain and range, and then I know the inverse flips it. So the range would become the domain, and the domain would become the range. That's one way, or the other way is simply to find the inverse, and then graph it and be able to identify the domain and range. So I'm going to do that instead. So it is an equation, starts with y equals. Remember, I'm going to come over to functions, hit miscellaneous if it's not already highlighted, and log base. Now this problem is a 2, it is a 2 down below, and use the arrows to get inside the parentheses in an x. So what is the domain and range? So I can see here that there is a vertical asymptote here at x equals 0. I can see that this purple line where represents the function is never going to cross the y-axis. It gets closer and closer and closer as it goes to the left, but it will never actually touch it. And if I'm able to take this and I am able to zoom out here, even though it's done very slowly, I can see this continues to rise as it goes to the left. It's very slow rise, but it continues to rise as it goes, to the right. It continues to rise. So I'm going to take this and I'm just going to draw a little picture for myself. So it looks something like this. All right, so this is the inverse. So the domain, the domain, it starts after 0, and there's no limit how far it goes to the right. And the range, there's no limit how low it goes, and there's no limit how high it goes. Even though it's rising very slowly, it still continues to rise as it goes to the right. So negative infinity to positive infinity. So domain, anything without 0 to infinity, I cross out. And we can see that D is the correct answer. This is kind of a tricky problem. So let me see if I can zoom in, because we will have to see the graph. So we do need to see the graph for this. So this says, for this particular problem, it says the graph we're looking at is g of x. It's not the inverse, it's g of x. And we want to find, what is this equivalent to? What is this equivalent to, okay? So let's go back to thinking about this. I know that for g of x, if I took the x and y, and then I look at the inverse, I'm just going to flip them. Remember, I'm going to flip the x and y when I go from the original to the inverse. Now, we already know the input for the inverse is -3. Well, the input is -3. That means, and that's like the y value. So over here, again, y is -3 here, so y would have to be -3 over here. See how I just simply flipped them? I just simply flipped them. So I want to know what x value with this original function, and this is the graph of the original function, what x value corresponds to y equals -3. So I'm going to find -3 here. So there's -1, -2, -3. I know it's very difficult for you to see here. This is the point right here. This is where it is -3. This is +4. So I know when I go to +4 for the original, I get an output of -3. And so then for the inverse, when I go to -3, remember this is only the graph of the original. When I go to -3, I should get an output of 4. Correct answer is C. Which of the following is the inverse of h of x equals 2 to the x? Again, how do we find the inverse? Well, I'm going to replace h of x with y. Then I'm going to switch the x and y. And remember, the only reason we the only reason we use or implement the logarithmic function is so that we can solve for a variable that's in the exponent position. So, how do I decide what the base is? It's whatever number you're trying to get rid of. Put everything else in place. On the right-hand side, these don't just appear, they turn into a 1. 1 times y is y. And I have log base 2 of x. Now here's the important part. We do need to write this. We need to write this in the correct inverse notation. What does that mean? We'll come back here. So it's h of x. We denote it as an inverse with a little -1. And then it's log base 2 of x. Now, if you had to type this in and it was not an option for multiple choice, if you just left it as a y, they would deduct points. So make sure you're writing these in the correct inverse notation. Again, the original is an h. We denote it as an inverse. This particular question asks us to analyze the inverse of this function. So I'm going to write down the function. And I'm already going to change this to a y. So y equals 4x minus 3 over 5. And now I'm going to switch the x and y. And to solve for y, this entire quantity is being divided by 5, so I'm going to multiply both the left and the right by 5. In doing so, they don't just disappear. They're going to simplify to a 1. 5 times x is 5x. Then I'm going to add 3 to the opposite side. 5x plus 3 equals 4y. Divide by 4. And now let's see what we have here. Before I go any further, let's see if I can answer any of the questions without having to graph anything. So I'm going to write this down. Okay, this is the inverse of the function. And okay, what is the domain? I'll have to graph that. What is the range? I'll have to graph that. What is the y-intercept? I'll have to graph that. Which of the following is not true? So there's one that's not true. And what is the constant? Constant means, sorry, what is the constant rate of change? This is referring to as the slope. This is referring to the slope. So I can come over here. And remember, the slope is the number that's stuck with the x. Now, by the way, the number stuck with the x is not just in this case the 5 in front. This 4 has to be shared with both the left and the right. So this is really 5/4 x plus 3/4. So keeping that in mind, the slope is not just 4, it's 5/4. Which of the following is not true? This last one is not true. The following shows two graphs that are not inverses of one another. So visually, remember what we could do is we could switch the x and y's. That would be one way. Another way, even easier, is going to be to graph the line x equals y. Now, how do you graph the line x equals y or y equals x? To graph that, every x value has to be the same as the y. So I start at the origin, and I go 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 4, and then down -1, -1, -2. I've got to see it here. It is difficult to see. Okay, I can see just here that it basically the top here, the top function, reflects across the line y equals x. So this is not true. This is actually going to be an inverse. I'm looking for what is not inverse. Okay, here we go. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Again, this did not show up great, but I can see again if I reflect across the line y equals x that the two are inverses of one another. Okay, so I got a 50% chance of getting this right. Let's do this one. 0, 0, 1, 1, 2, 2, 3. Okay, so here is an example. Now, I wish that these were color-coded. I don't have the ability to do that, but maybe I can use just two different colors here. So here's red. Here's blue, representing the two different functions. And if I folded them along the orange line, which represents the line y equals x, they would not reflect across it. They would actually reflect across the y-axis, if you can see that. They reflect across the y-axis, not across the line y equals x. These are not then inverses of one another. But let's show how the last one does work. The last one, if I did, again, 0, 0, 1, 1, 2, 2, 3, 3, and so on, I can see the two inverses. I think it is easier if we do color-coded here. There's one. And there's 2. We can see that the 2 actually do reflect across the line y equals x. So C is the correct answer. Match each graph with its inverse equation. Okay, so what we have, match each graph with its inverse. So we have here, listen closely, these are all the originals is what it's saying. This is like f of x, g of x, h of x, k of x, just making those up. These are all the originals, and it says up here are the inverses. So I couldn't graph that. I couldn't graph option I, and it would look like one of these. This is the inverse of one down below. So here's what we're going to do. I'm going to zoom this out real quick, and I'm going to look with what option do I think looks easiest first. I'm going to start here because I have a list of ordered pairs. So I'm going to start here, and I'm going to go, does any of these have 1, 0, or 1 and 2.5, or 6.25 and... Did I mix that up here? I think I mixed up the here. 1 second. So this should be 0.4, 1, 2.5, and 1. So I just flipped the x and y's. This now becomes the x, and this becomes the y. Remember, because when we go from one inverse to the next, the domain and range are going to flip-flop. So I'm going to look through this graph and find out, is it possible, this would be the easiest one to look like, that has a 1, 0. 1, 0. Okay. Here's 1. This does not have a 1, 0, okay? This does not have a 1, 0. This has a 1, 0. This has a 1, 0. So it's one of these two right now. It's one of these two. Let's go up to another one. Let's go and see, does it have a 2.5, 1? Does it have a 2.5 and 1? 2.5 and 1. Well, I can see here is a 2. Here's 3. 2.5. So here's 1. So 2.5, again, here's 3. 2.5 is right there because here's 0, 1, 2, 3. So here's 2.5, and I want it to have a 1. That's really close to having a 1. That may be it. Let's check this one out. Doesn't look exact for me, though. Here is 3, and I want 2.5, and there's exactly 1. This is going to go with this one. Now let's just make sure. I'm going to keep going just a little further here. I can't go any extreme further because I cannot find 6.5 here. I didn't show enough of the graph. I can't find 6.25. Here's 5. Here's 6 way out here. And 6 would look like it would go almost, oh my goodness, I'm so sorry you can't see here. Let me zoom this out so you can see a little better. I am so sorry. So I have confirmed that these two do lie in the last graph, but it was so close that I want to use one more point to ensure that I'm choosing the right graph. So I'm now going to approximate where 6.25 is and make sure it goes with 2. So down here, this is 1, 2, 3, 4, 5, 6. So here's 6. 6.25 is just about right here, and it should match up with 2, which it does. That means that graph D goes with this option. So I came down here. For your test, you're just going to have to pair them. I think you get to move the equation over the top of the graph, some type of visual like that. I'm going to cross this out. Okay, let's go to another one. Let's go to a point here. Let's choose this point. Let's choose this point real quick. So this has the point. Everybody can see this has the point right here. This is 0, 1, 2, 3, 4, right? This has the point 1, 0. So in the inverse up here, so if this has the point 1, 0, then up here it would have to have the point 0, 1 because I'm simply flipping them, right? So only one of these three, when I plug in an input of 0 should get an output of 1. Okay, so let's do this. Plug in 0. 0 cubed is 0. 0 times 2 is 0. 0 plus 1 gives you an output of 1. I think this is the answer. But let's check this one. If I plug in a 0, input is 0. 0 plus 2 is 2. 5 divided by 2 does not give me an output of 1. Plug in a 0 here. 2 times 0 is 0. 0 minus 1 is negative 1, not an output of 1. So this choice goes down here into this option. This is option number 1. Hold tight, guys, 2 left. So I'm going to come over here and I'm going to find a good intersection point, a really easy one. Here's one right here. So this has over 1, up 1. So this has the point 1, 1. Well, that makes it easy because when I take the 1, 1 and I flip them, I still get an answer of 1, 1. So of the 2 choices remaining, only one of these should have a 1, 1 answer. Let's check. So if I input in 1, 1 plus 2 is 3. 5 divided by 3 is the output. 5 divided by 3 is output, but the output should be 1. Doesn't go with that. 2 times 1 is 2. 2 subtract 1 is 1. That should be the output. That means this choice goes here. This is option 3. There's no reason for me to do the last one. There's only one last choice, and that would have to be the remaining one, which is 2.